We're going to be taking a look at the Jonesboro, Arkansas EF3 tornado from the 28th of March, 2020. We're going to use multi-radar, multi-sensor system MRMS products to add some additional warning decision confidence. One of the MRMS products we have at our disposal is the ProbSevere model. We're going to go to the NOAA SIMS webpage and go back in time about 2 weeks to 28th March 2020 and take a look at the Jonesboro, Arkansas EF3 tornado that rolled through there. This is a statistical model designed to improve your situational awareness, increase your forecast confidence, and hopefully lead time in a severe thunderstorm or tornadic thunderstorm type situation. The model contours each convective cell that it identifies, and the color of that contour, the hotter colors, the purples, tend to be the high end of the spectrum towards 100%, and the blues are in the low end of the spectrum towards 0%. That color contour directly is a result of which algorithm output is the highest, the severe hail, the severe wind, or the tornado. Severe prob is the result of those three. Whichever one's the highest, that drives what the ProbSevere contour is. The short-term 0 to 60 minute nowcasting type tool, similar to radar. The reason for that is it's got a lot of radar ingredients in it. We can use it. It is available as a GR2 place file, and the operators like it. We get a lot of good feedback. The prob hail and prob wind legs of the ProbSevere algorithm get their information from model data, lightning data, radar, and satellite. ProbTor, though, primarily is model data and radar data with just a splash of some lightning data. ProbSevere algorithm performs pretty well in comparison to a skilled forecaster. In the probability detection, fairly similar, comparable numbers. False alarm rate, very comparable as well, and skill scores also, but does fall short in all three categories. Keep in mind also, false alarm rate for both the forecaster and the ProbSevere are pretty high, near 60%. Where it excels is in the lead time, more than double that of the skilled forecaster. So I believe this is why it gets pretty good feedback most of the time from the operators. This is Tom Herman. We're back. I'm going to take a look at that Jonesboro tornado using ProbSevere. It's a model built by SIMS, co-op between NOAA and University of Wisconsin. It's posted on Wisconsin's page. Just do a simple Google search for ProbSevere, and the first link that comes up is going to be our webpage. It's very logically intuitive, and I just kind of jumped in there and switched on you and put the 28th of March in. So you can go back quite a ways. We've got the 28th at 21Z through the 28th at 2230Z. So shorten that loop up a little bit. And it's looping every 2 minutes, or it's a new frame every 2 minutes. And we can kind of get an idea of the Jonesboro area here. I've got the ring around the airport and then a 5 nautical mile radius around that. So we're going to emulate that we are putting a tornado warning out for Jonesboro Airport for the 5 nautical mile aerodrome with 15-minute desired lead time. So starting out in the loop here on our first frame, we're at 21Z. That's approximately 1 hour prior to the first arrival at Jonesboro. So I've got composite reflectivity on here, our the warning boxes, and our ProbSevere contours. So this contour down to the bottom left there has pretty good ProbTor in it, probability of tornado. Thing you need to know, if you mouse over, you get the tile opens up and has all the ingredients in there that generate the probabilities for probability of hail, probability of severe winds, and probability of tornado. And whatever the highest probability of those three is, that's the contour, the shade of the contour. So you're going to get a ProbTor, in this case of 51, because a ProbSevere, because the ProbTor is 51%. The tile goes on to add in there what the ingredients are, all the way from maximum expected hail size, build density. So these are radar derived products, elements rather. The ENI, Earth Networks, flash rate, cloud to ground flash rate, and flash density. You also get some more radar indications from low level azimuthal shear. Those are important for the prob tour. Let's see if we can get it to display a little bit more of that. So it's a little flaky. There we go. All right, so we got the flash density, the as shear. So anything over on the as shear, anything over about 0.1 is considered to start being significant rotation, tight circulation pattern, tight and strong. Normalized vertical growth rate is from infrared satellite imagery. Shear is from model data. MU cape also model data. The mean winds also model data, wet bubble zero, etc. And the cape. GLM is GOES lightning mapper. Right now that's just on there for your information. It does not go into the ProbSevere or any of the prob algorithms. You also can pin this to the screen if you'd like to have a little more static impression of what's going on there. But right now, here's Jonesboro. These cells are inbound from the southwest, and that's what we got to start watching. So this gives us a good kind of at least get the watch out, if not the warning in time. And as we move along, the contours turn more purplish. You have a higher ProbSevere content in there. So at this case, at this point, Prob Tour or Prob Tornado is 62%. To me, it's heading in the right direction towards Jonesboro. I at least want to have the watch out by this time, although it's probably, if you want an hour lead time, we'll be chewing into that a little bit. It's 21:06 at this point, but the Prob Tour is 62%. National Weather Service is most likely going to issue a tornado warning, and there's the polygon right there. And it was issued at 2059, so this is a little bit older. So they were watching this a little closer and a little earlier than what we set this up for. So there's another couple frames, so 21:08. So this is every 2 minutes, 21:10, 21:12. Let's get about a half hour prior right there. We're still cooking pretty good. We've got Prob Tour 28, Prob Wind of 47. Still have tornado out, warning out. And we can see as this rolls in, we're getting better and better returns on radar and also subsequently on ProbSevere as well. They're backed off a little bit. More bluish the contour. That's the low end. The purple is the high end. So you see it as it gets closer and closer. We're getting the warning boxes out there, and we've got Prob Tour 13% ProbSevere, probably running about in the mid 30s. There we go. So there it's really lit up as it's getting close to Jonesboro, and we got Prob Tour 40 there. Prob Tour 40, Prob Wind 52. Right there's about when the first report happened, just to the southwest. There's 21:57, large tornado on the ground going through Jonesboro. So at that point, we would have had a tornado on station. We would have been able to verify. And a couple minutes after that, we do get a storm report of wind 74 miles per hour over the airport. So ProbSevere, in this case, ended up being a very good situational awareness MetWatch tool. The Prob Tour portion of ProbSevere is highly dependent upon kinematic environment, and those measurements are dependent on how well the model is doing. Those are model numbers. So if the model's not doing well, then keep that in mind that Prob Tour is probably not going to be doing well either, or most of the ProbSevere suite will not be doing well. It's best to use the nearest neighbor comparison with Prob Tour. If numbers are higher with one cell, that should be your focus. That one's probably going to be given higher numbers or higher probability of producing a tornadic cell. And keep in mind, from event to event, the same numbers don't necessarily guarantee the same outcome. ProbTor does have some limitations, and most of them are radar related, since it's a fairly hefty input to the algorithm. When you have linear systems, quasi-linear convective systems or squall lines, there's a couple of situations where the ProbTor has some issues. It's got to be able to identify a single object. And sometimes when cells are clustered in a line like that, it's hard for the algorithm to distinguish between separate objects. And it may fail to contour a particular item. And don't be misled that because there's not a contour does not mean there's not still a tornadic threat in that area. So keep your eyes peeled. Use NROT and GR2 or the Shear feature rotational tracks from some of the MRMS, the other MRMS products to track the shear in a line, keep you focused in the right spots. And then also occasionally it will just contour the whole line as one item. So that can be a problem, and it'll over forecast especially if the model numbers are really high for shear and cape in those areas. The other limitations are typical radar ones: beam blockage, noise in close to the radar. Land spouts and water spouts are too small to be detected, so it's not going to provide a good correlated probability for those areas. And it'll also under forecast tornado probabilities when the model data storm relative helicity values are too low compared to what's really going on. We reviewed some of the limitations with ProbTor. Overall, ProbSevere does have some limitations as well, some tied directly to the ProbTor limitations and others directly tied to typical radar limitations. And we'll review those again real quick. The noisy area inside of 10 miles from the next rad radar. So kind of use that with a grain of salt in that area because the shear may be artificially high in those areas due to noise. Beam blockage again, and also increased beam height away from the radar. So if your cell is more than about 60 miles from a next rad, you're going to start to, maybe have some issues there as well. The quasi-linear convective system or squall line, same issues, both ends of the spectrum. Either it might miss identifying an object in the line, and it may identify the whole line as one object. So that can be an issue as well. Also, if it's tuned for downrush type winds, prob wind is, and if you get a microburst and winds outside the reflectivity core, it's going to under forecast for those. So keep that in mind as well. It does the best when satellite can observe development of the storm from immature cumulus up to a cumulonimbus stage. To sum up ProbSevere, it's once again a statistical model incorporating numerical weather prediction models, radar observations, lightning observations, and also METSAT or satellite information as well. And it is a nowcasting tool for the next 0 to 60 minutes. All the models should be used in conjunction with existing radar interrogation techniques, and it's going to help to increase your confidence, increasing lead time. That's its strong suit, is the lead time on severe storms. ProbTor, best to use in relative sense. Once again, use it to the nearest neighbor, comparing which one has the best probability the threshold will reach tornadic. ProbTor is fairly well calibrated, so a storm with 33% probability will produce a tornado about 1 in 3 times, and so on. ProbTor values fluctuate in response to changes in the strength of storm rotation and the updraft. So the model may not pick up on it, but live radar would. So always be using it in conjunction with it. That's why the place file overlay for GR2 is so important. Right now, GOES Lightning Mapper information is not incorporated into the algorithm. It's just posted in the tile for your information at this point, but soon to be evidently included into the algorithm. GR2 place file for a ProbSevere loop, the 1-hour loop, is available. A Google search will render your your URL, or you can just copy this one in. It's Iowa State, and available on Red Team Weather, their website, if you want to just copy and paste it off of there. And once again, works pretty well to supplement live radar data. All right, let's take a look at the Jonesboro EF3 tornado from the 28th of March 2020 using an MRMS product, which is multi-radar, multi-sensor system, off the Severe Storm Labs page. And just do a simple Google search for MRMS and ProbSevere will work. Now, the first link is the operational viewer. We don't want that right now. If you were live, if you were Met watching live, you'd want to use the operational product viewer, but we need to go back in time, so we're going to have to go to the main page and get the experimental link set up here. There's a breakdown on this. This is the home page. Tells you what all goes into MRMS, radar mosaic, multiple radars, satellite imagery, lightning data, model data, climb mode data, all put together to create high spatial, temporal, and temporal resolution mosaic. First link there is the operational product viewer. We're going to skip that. Once again, we're going to go to the experimental because we need to go back in time. And Jonesboro sits about right there in northeast Arkansas. We'll get that fixed up here in a second, get zoomed in and located over there. Getting close there. Let's see here. Pan and zoom controls are a little different than probably what you're used to. So Jonesboro sitting on about a zoom level 10, I think works pretty well. What we're going to be doing is we're going to be simulating issuing a tornado warning for the Jonesboro airport and a 5 nautical mile radius around that airport. Now we can't set up range rings, but a 5 nautical mile radius put us about right through this kink in the highway, and that one as well, about right there. And that's what we're interested in, watching from the southwest corner. Stuff's going to be moving from southwest to northeast. So the product we're interested in, again, we'll get that set up, is going to be the rotational tracks right there. Let's get our calendar set. I promise you we go back and look at March the 28th. So there's March. Pick the date, the 28th. Now the hour, or rather the time we're setting, is going to be the end time of the loop. So it occurred around 22Z. So we're going to go 22 and add about 20 minutes after that. So our loop's going to go up through 22:20. So here's the rotation tracks. Occasionally you'll see it in certain formats represented as rotational tracks. But here it's rotation, and it takes the maximum azimuthal shear in a layer across a given period of time. The layer we're interested in is the low level, and that's going to be 0 to 2 kilometer, and then the mid level would be 3 to 6 kilometers. So we're also interested in a 30-minute scoop of the data, and I'm going to set up the loop here, and we'll pause it immediately once I get it started. There we go. And I'm going to go 36 frames every 2 minutes, kind of maxing it out. A nice smooth loop running. And we're going to see it approach from the southwest once again. So start time's 21:30, so about 32 minutes prior to the event hitting the airport. But by 57 after or so, it's within 5 by 21:57. So we're going to watch that very closely. I set my loop speed to slow. I forget to do that a good bit, and it's hard to keep up with a large scale like that. So unselect the pause. So this is about 50 minutes prior to arrival, and we can see there's some very lit up colors there in the hot range. Anything up above about yellow or 0.01 or above is significant azimuthal shear, so that needs to be watched closely. So this should launch you into a more effective or more intense radar Met watch. Also, when you start seeing numbers like this and those hot colors rolling in towards you, and it appears to have quite the track. Now at 21:20ish, there were a couple of funnel clouds reported down here as well. So you got good verification, real-time verification happening on the spot there with this loop. Let me try to zoom up one more notch here. Now we kind of seen the way things are going. Here we go. And I'll have to run through the whole loop to get it reset here. kind of spoils it, but all right. So we can see some sporadic stuff sitting around as well. So there's maybe some showers with some rotation, spinning them around a little bit there as well. But we can see it approaching from the southwest. There's about 1/2 hour prior. So we got these real high value numbers coming in. Should be good alert for you to get your Met Watch started. Once again, an intense radar Met Watch. So this is about a little less than 15 minutes prior. So that's of it hitting the airport. So we're already into the time frame where it's going to get within 5. So we can see as it's coming across, we've got numbers that end up being off the scale. So above 0.2 here in another frame or so, about right there. And it's right over Jonesboro. So that's the EF3 ripped right through town and also through the airport on the east side of town. So this ends up being a real good Met Watch tool.